So if you're sitting here at this point, you should have already learned that a decibel is a relative measurement of power. Relative measurement of power. Now let's put some numbers to it. RF math, which sounds kind of scary, isn't really that bad. There's only a few things you'll ever do with RF math, and it's things that you can do. So let's first look at what is the value of a decibel. That's done by looking at what's called the rule of tens and threes. The rule of tens and threes says this: if you lose 3 decibels, you are left with 1/2 power. If you gain 3 decibels, you now have 2 times your power. Oops. If you lose 10 decibels, you have 1/10 of your original power. Gain 10 decibels, you have 10 times your original power. With these two numbers, you can do anything with RF. Anything with RF math and decibels, you can do. The idea behind RF math is to apply these rules properly. There's a few different sections you have to do this. This is going to be the fundamental one that's going to take you on to the next level. It doesn't get harder, though. No, I just want to scare you. Let's look at a scenario when this RF math helps. You have an access point. That access point has a transmitting power of 100 milliwatts. Out of it has a cable that connects to an antenna. You know that that cable has a 3 decibel loss. Now, by the way, where do you learn what loss cable has? You look it up. Depending on the cabling type, they're different. They're just standards that you can look at and say, well, this cable type has this much loss per 100 feet. Do some simple math and you can get that. So we're saying this random made-up cable has a 3 decibel loss. We're saying this antenna is a 10 dBi antenna. The thing I want you to know about a 10 dBi antenna, don't be afraid of that I right now. It doesn't change anything. It's just proper nomenclature for decibels of an antenna gain in dBi. So we have a 100 milliwatt transmitter, 3 decibel loss, a 10 dBi gain. Your job is to tell me, how much power comes out of this antenna. By the way, that is called EIRP, discussed in a previous video. So how do we do this? The way I do it is I first look for patterns. 3 and 10. Hey, look, that's pretty easy. What if this was a 9 or a 7? That gets a little tougher, but for now, I notice that and I say, hey, look, this isn't bad. Then I follow the power. I am 100 milliwatts when I leave this point right here. When I leave this point, I'm 100 milliwatts. When I get to the end, how much am I now? I have lost 3 decibels. 3 decibel loss is 1/2 of my power. What is half of 100? 50. Now I am at 50 milliwatts. Not too bad, right? All I had to do was cut something in half. But now I'm going into an antenna that has a 10 decibel gain. What is a 10 decibel gain? By the way, there's never a negative antenna. It's always a positive. So a 10 dBi antenna tells me it's 10 times the original power. What's 50 times 10? 500 milliwatts. So the EIRP of my system is 500 milliwatts. If you can follow along with that, you just did your first RF math problem. Now, what happens if I start to throw maybe a few wrenches in the works? What if we get rid of this here, and I make this a 6 decibel antenna? No, sorry, let's make it a 9. I like 9 better here. What if it's a 9 dBi antenna? 100 milliwatts goes in, I lose 3, half my power is 500, but now I have 9. 9 isn't up here. So what do? Pretty simple. How do I get 3 decibels to 9 decibels? I do it 3 times. So 50 milliwatts goes in. So 50 milliwatts plus 3 dB, 3 times, plus 3 is my 9. The one thing to understand about this, where I've seen a lot of people make mistakes, is don't put the 50 into each one. 50 plus 3 decibels would be double the power. That equals 100, right? You can't do 100, 100, 100, and then add them up. You'll get the wrong answer. They go one into the other. So 50 milliwatts goes into 3 decibels. When it encounters a 3 decibel gain, that's 2 times the power. I now have 100 milliwatts. If I ever forget the milliwatt, it's implied. Now the 100 goes into 3. 100 milliwatt encounters a 3 decibel gain. 2 times the power is 200 milliwatts. Same thing again. 200 goes into encounters a 3 decibel gain. I now have 400 milliwatts, which is my EIRP and the answer to this question. Let's look at another way to do this same problem. These are the patterns I want you to start seeing when you get some RF math problems. Sorry, I need to leave that a 9. The patterns I look for is I see 9 and I see 3, and I know, because I've done this a few times, the work I'm going to have to go through to get, I'm going to have to minus and then plus. But you can look at 9 minus 3 is 6 decibels of total gain. Now remember, we're not doing 50 milliwatts anymore. We accounted for that here. 9 minus 3 means our whole system, antenna, gain, and loss of the cable, gets me a total gain of a 6 decibel gain in my system. 100, so 6 decibels, is a plus 3 plus 3. So 100 milliwatts goes in, encounters a 3 decibel gain. I'm now at 200 milliwatts. That encounters a 3 decibel gain, and I'm at 400 milliwatts. The exact same answer we had last time, maybe one less step to do that. So that's kind of a shortcut to getting this. Now, there are times when I will throw you a little bit of a wrench here. And what if I were to do this? What if I were to say you have a 2 decibel loss and an 8 dBi antenna? You're probably saying, okay, this is a little scary looking. How do I get 2 when I'm dealing with 10s and 3s? How do I get 8 when I'm dealing with 10s and 3s? You're actually going to learn that. But this particular question is where you start looking for patterns. What I see when I see this question is 8 minus 2 equals 6. I know how to work with 6 because that's really easily divisible by 3. So that is an example of when you want to kind of look at these numbers, not individually, but from afar and say, okay, I can see how the total system is really only a 6 decibel gain. I am going to, there's going to be a few sections on RF math. This is basically what you could call system RF math. If I have a system of transmitter and losses and gains, and by the way, we can keep adding these. We could have an amplifier. We could have loss through the air. You're going to see this in our link budget calculation. You're going to use some RF math there. That I could do losses and gains, and I could come up with numbers. But this is the core of it. I'm never going to make this more complicated than what it is. That's all it is using 10s and 3s. One thing I have found that students can kind of get scared is when, what if the number was something like this? What if it was 3 and 7 is a good example. Well, 3 decibels, 7 minus 3 is 4. That doesn't feel like it helps us, and it doesn't in this case. So I'm sitting here at 50 milliwatts, right? 100 encounters a 3 decibel loss. I have a 50 milliwatt intentional radiator. Now I encounter a 7 dBi antenna. That can get kind of frustrating to deal with. We have 50 milliwatts coming into 7 dBi. Here's the cool lesson. You can do whatever you want with those numbers to get that number. How do I do that? 7 decibels is a plus 10 minus 3. That's plus 10 decibels minus 3 decibels gives us our answer, so let's do it. 50 milliwatts goes into a 10 decibel gain. I am now at 500 milliwatts. That 500 milliwatts encounters a 3 decibel loss, right? Because we're trying to get to 7, so we have to do 10 minus 3. 500 gets cut in half. We are now at 250 milliwatts, which is the answer to this question. I hope that makes sense, and you can use any combination. In fact, let's go ahead and just do this. Because it can feel a little confusing, I'm going to show you a chart how you can achieve any number with a rule of 10s and 3s. And there's actually multiple ways to do a few of these, so I'll just show one. So let's do one. How do you get to a 1? Plus 10 minus 3 minus 3 minus 3. Okay, so we're going to use 10s and 3s to get to 1. So if I had something that was a 1 milliwatt gain, or sorry, 1 decibel gain, plus 10 minus 3 times gets us to 1. 2, a couple ways to do that. Plus 3, plus 3, plus 3, plus 3. 3 times 4 is 12, minus 10. So this one is, of course, just an easy plus 3. Here, plus 10 minus 3 minus 3. So I'm plus 10 minus 6. 5. Again, a few ways to do this. Here's another. So we're going to do the opposite of what we did here, is to show you. You could do plus 10, take you to 20, and then minus to 15. So it looks kind of crazy, but this is what you have to do. 5's a weird one. 20 minus 3 gives you a relative gain of 5 decibels. Plus 3, 7. We did that one. Plus 10 minus 3. 8 is, you can do it like this. So the 8 you can do plus 10 takes us to 20, minus 3 minus 3 minus 3 minus 3. So 20 minus 12 takes us to 8, plus 3 times, and then of course 10. So once you start hitting 11, you're going to figure this out. You're going to say, oh, okay, the patterns don't change. I'm just going to start, add another 10 up here. Now I'm sitting at 11. So you can get to any number using the rule of 10s and 3s, and you want to learn to do that. It looks cool. I don't know how often you'll use it. For those of you studying for your CWNA, you got to know this. People make or break the test a lot of times on this, and it's really not that hard. So go through this video again if you need to. Make sure you understand some problems. You can find some practice problems, and make sure you work through those exercises to do that. Here's one place where I've seen people make an error, so just be aware of this. When you're adding and subtracting 3, make sure that 3 equals a double or 1/2. A lot of times I'll see people do plus 2 decibels is 2 times, because 10 and 10 makes sense. 3 and 2, people sometimes transpose those. So some people say, well, plus 2 is double. It isn't. It's plus 3 is double, and minus 3 is 1/2. So I've seen people do that. Just try to be aware not to. Hopefully this gives you a solid start in RF math. In an upcoming video, we're going to talk about converting milliwatts to dBm. So those little letters after dBm, dBi, we're going to learn how to apply that. It's going to be the exact same thing, except we're starting with a reference point.